I am Miss Yvette, better known as Layla's mom, and I have the pleasure of introducing you to our learning series, Simple Machines. And throughout our series, we're going to talk about different types of simple machines, and hopefully you'll be able to learn information that will help you to apply these different simple machines to your upcoming robotic mechanical builds. All right, let's get started. The simple machine that we're going to talk about today is going to be the wheel and axle. If you look at our diagram that we have here, you'll see the wheel and axle is exactly what it sounds like. It's a wheel with a rod that goes through the middle, which we call our axle. There are a couple of terms that we need to know as we're going through this series, and as we're learning about our wheel and axle and other simple machines. We're going to apply these same principles to our other simple machines. One of the main things that we want to understand, the reason why we use simple machines is because they actually allow us to gain mechanical advantage. Mechanical advantage is just as it states, is the advantage gained by the use of a mechanism and transmitting force. So mechanical advantage doesn't decrease the amount of work that's being used, but it actually changes the level of force. So it makes the job easier. It's not changing what's required to get the job done, but it's making it easier for the user. Another word is torque. We're not really going to get too much into torque, but I did think you need to understand what torque is, being that we are talking about a wheel and axle, and that's the turning or twisting of force. We're going to talk about the diameter. The diameter, if you need a refresher from math class, is the length of the straight line through the center of an object. And then we have our circumference. The circumference is going to actually be the distance all the way around our circle or the perimeter of our circle. And then we have our radius. Our radius goes from the center of the circle to the actual side of the circle or the circumference, or wherever that bounding surface line is. That's going to be our radius. So if you look over here to the left, we have an example that's going to help you to understand how to actually get the mechanical advantage of different objects. So if you want to increase your mechanical advantage, this is how you would go through and figure out what your mechanical advantage actually is. So we're going to divide the radius of the wheel by the radius of the axle. And if you don't have the radius, this is where it comes into play, understanding what our diameter circumference is, because we can actually use our algebraic terms and work backwards so that we can identify our radius. And we're going to use this for both. So if you want to find a mechanical advantage, you're going to have to find the radius of your wheel, and you're going to have to find the radius of your axle. I also included pi just as a reminder in case some of you're not familiar with the symbol, or you're not familiar with what pi stands for. So if you look down there to the bottom, and normally we just stop at 3.14, but if you want a more accurate number, you can put it all the way out, normally to like this about 6 or 7 different decimals, because as we know, pi just keeps going on and on and on. But that's the number that you would use to help you with this equation. All right, so now we have an opportunity to look at some of the examples of this simple machine. And we're going to actually talk about how can this simple machine make things easier. Imagine if you had to open a door without a doorknob. You could simply push the door. You could pull the door, you could lift the door. There are a lot of different ways that you could still get into the room. But as you know, in our day and time, we're accustomed to using a doorknob. And if you didn't know, now you know. What makes that doorknob work is a simple machine, or it's a wheel and axle. So the rotation of the doorknob is actually what turns, and then you're able to pull it so that it decreases the amount of it makes it easier for you to actually open up the door. It's the same with a pencil sharpener. Well, old school pencil sharpener, because I don't know if a lot of students still have mechanical sharpeners in the classroom. But this is an example of a mechanical sharpener, and it's the same principle that's being applied. If you look and you see the yellow arrows, that's showing where you're turning the handle, which is like a wheel, and that handle is attached to an axle. And when you put your pencil in, that turning is what's allowing the inside of the sharpener to go around your pencil and to sharpen it. It's a lot easier than if you try to do it manually. Even a skateboard, something that you may not even think would have a simple machine, it has a simple machine, because the wheel and axle is actually what allows you to glide up and down on your board. Just imagine trying to make that action without a wheel and axle. And I guess it would be similar if you think about if you took a skateboard and you put it on snow. Now you have a snowboard. So now you're moving because of the decrease of friction on your board and your snow. But if you take that same board and you try to move and apply more friction, you're not going to be able to glide with the same amount of force. But if you add a wheel and axle, it will allow you to move at a better rate. Now, if we look down here towards the bottom, we have the fun stuff, robots. And a lot of times with our robotic builds for competition or when we're just trying to solve different problems in class, we forget that we have to understand our simple machines, or how to apply our simple machines, so we can understand what the mechanical advantage is for our robotic build. In many cases, when we are building our robots, we forget there is a purpose behind why we're building this robot, and there also is a process that we should follow to make sure that we're getting the most out of our mechanical build. So in this case, we have a couple of examples, and one of the examples will be the bottom left. As you can see, which we've talked about in our previous pictures, we have a wheel and axle, and 9 times out of 10, this is just so our robot will be able to move forward, or it will be able to move backwards, so whatever our rotational motion is, and it'll be able to move at a better rate because we have a wheel. Another way we can apply our wheel and axle to robotics would be the claw. If we look at the claw, at the top of the claw, right here, if you look at my cursor, we're going to use the wheel and axle to actually lower and lift our claw arm. So this time, we're not necessarily using it to move our actual bot back and forth, but we're actually using it for operation that we have attached to our actual robotic build or robotic mechanism. And then if you look at our picture over here, this is another example of how we're using our wheel and axle. In this case, we're actually using it to lower and lift an object. We have our wheel and we have our axle, which is underneath our assembly system. So we actually have some tread attached, and the tread is going to grab the ball as it's moving on a wheel and axle to rotate this tread up and down. We're going to grab our ball, and it's going to actually cause our ball to be lifted. So those are 3 different ways that you can use your wheel and axle in a robotic build. And at the top are 3 different ways we use our wheel and axle in everyday life. So now we're to the fun part. First, I want you to remember, before we get to our challenge, I want you to remember simple machines do not enable you to do less work. Rather, they enable you to use less force. So the same amount of work is being done. It's just allowing you to do it easier. So for our challenge, what I want you to do, I want you to go on a scavenger hunt around your house. And I want you to find wheel and axle simple machines around your home or in your community. It's nice in El Paso. Wherever you are, if the weather is not as nice as it is here, just go around your house. You will be surprised at the different locations where you'll actually find a wheel and axle. After you find your wheel and axle, I want you to try and figure out the mechanical advantage of that item. So I want you to go back and I want you to look at the information that we provided on how you find your mechanical advantage, and I want you to see if you can figure out through measuring, remember, the radius of your wheel and the radius of your axle. See if you can figure out what type of mechanical advantage that wheel and axle is providing. With your parents' permission, please make sure you get your parents' permission, because you would be using social media in order for you to share your findings. So after you ask your parents, or ask your parents if you can go on their account, or even better yet, share with your parents what you found and ask them if they will share it on their account. What I want you to do is take a picture of what you find and tell us what the mechanical advantage is. There are two ways that you can share your information. You can share your findings at Twitter, and you can hashtag laylasleague.com, or just send it directly to our Twitter site. Or you can find us on Facebook, and this is our UIL on Facebook. Or you can just do a search for Layla's League LLC, and we should also pop up. Again, make sure you ask your parents for permission before you put information on the site. I would like to thank you for taking a brief moment today to learn about wheel and axle, simple machines. And if you have any additional questions, please feel free to email me at yvette@laylasleague.com, or you can always send a message at our Twitter account, Layla's League, and our Facebook account, which is seen right here below. Thank you again for tuning in to Layla's League.